All right, this is a quick study guide for surface water math, 20 questions. Preface, I claim no ownership to any of these questions or the material. I've sourced everything off the internet and the slides. I answer the questions to the best of my knowledge. Again, it's a study guide for me. If it can help you, that'd be good too. Question 1. What is the flow rate of water in gallons per minute through a plant that treats 1.5 million gallons of water per day? All right, so we're going to have to do some converting. So you have 1.5 million gallons per day. So we're going to convert that to million gallons. To convert million gallons a day to million gallons, 1.5 million gallons a day times a million. And for that, 1,500,000 gallons a day. I don't know about your state, but the state of Florida gives you conversion sheets. I suggest that you use the formula sheets while you practice, get familiar with them. So again, the question was asking for gallons per minute. We have 1,500,000 gallons per day. You want to convert that, you can see that 1 day equal to 1,440 minutes. Therefore, 1,500,000 million gallons a day divided by 1,440 minutes in a day is going to give you the answer of 1,042 gallons per minute. Question number 2. What is the flow rate of water in gallons per minute through a plant that treats 2 million gallons of water during an 8-hour shift? Thing I'm going to do 2.0 million gallons, million, give us 2 million gallons. And for an 8-hour shift, divide the 2 million gallons, 8 hours, give you 250,000 gallons per hour. Convert that to gallons per minute, 250,000 gallons per hour treated, divided by 60 minutes an hour, gives you 4,166.66 gallons per minute. Round to 4,167 gallons per minute. C. Question number 3. What is the volume of a pipe that has an inside diameter of 8 inches and is 1,500 feet long? Again, this comes off of the formula sheet. It says 8 pages for the state of Florida. I recommend getting used to it and where things are for when you take your test. So we're solving for the volume in a pipe, and they give us diameter. Volume of a pipe with diameter, 0.785 diameter squared. Height is going to be length, height are the same thing. Volume gives you cubic feet, so you have to convert the inches into feet. Gave you 8 inches. Of course, 12 inches in a foot. 8 inches divided by 12 inches per foot gives you 0.67 feet. All right, now they've got the 0.67 squared times 0.785 times 1,500 feet long. The answer is 528.57. It's cubic feet. Left that out. So cubic feet. You solve for volume, you get cubic feet. So question number 4, given the previous answer, what volume in gallons would this pipe hold? So again, conversion sheet. So the previous answer was 528.6 cubic feet. 1 cubic foot is 7.48 gallons. If you multiply 528.6 cubic feet, 7.48 gallons per cubic foot, that would give you 3,953 gallons in that. All right, question number 5. What is the Weir overflow rate of a circular sedimentation basin that has a circumference at the Weir of 300 feet? Assume that flow into the basin is at 400 gallons per minute and the basin is full. All right, so we're going to have to do multiple conversions on this problem. The Weir overflow rate formula is the total flow gallons per day divided by the length of the Weir in feet. Here it is again, Weir overflow rate, total flow gallons per day divided by length of Weir in feet. They've already given us the length of the Weir, so 400 gallons per minute divided by 300 feet. That's going to give you an overflow rate of 1.33 gallons per minute per foot. Question number 6. What is the Weir overflow rate of a circular sedimentation basin that has a radius of 30 feet? Assume that flow into the basin is at 150 gallons per minute and the basin is full. And Weir overflow rate, total flow gallons per day divided by the length of the Weir. So they gave us the radius in this problem, and we need to solve for the circumference to get the length of your Weir. The circumference, circle is 3.14 times diameter. Again, to get the diameter, and the radius times 2 equals diameter. 30 times 2 gives us 60. 60 times 3.14 gives us 188.4. 150 gallons per day divided by the length of the Weir, 188.4. They give you an overflow rate of 0.796 gallons per minute per foot. Question number 7. What is the detention time of a rectangular settling basin which measures 15 feet wide by 25 feet long by 10 foot deep and receives a flow of 250 gallons per minute? Formula for detention time: tank volume in gallons divided by flow rate gallons per day. In this problem, it's in gallons per minute. Detention time, gallons per minute, because that's what it's asking for. Tank volume in gallons divided by the flow rate gallons per minute. The volume of a rectangular basin is length times width times height. Remember, it's cubic feet, already in feet. So 15 by 25 by 10 gives you a tank volume of 3,750 cubic feet. You have to convert cubic feet to gallons, right? Because gallons per minute is what they want. So 1 cubic foot is 7.48 gallons. 3,750 cubic feet of volume times 7.48 gallons per cubic foot gives you 28,050 gallons. And that by the 250 gallons per minute, give us the answer of 112.2. All right, question number 7. Solve the previous question if the answer wanted units in hours instead of minutes. So we had the detention time in minutes, which was 28,050 gallons divided by 250 gallons a minute, which gave you 112.2 minutes. Convert this, there are 60 minutes in 1 hour. 112.2 minutes divided by 60 minutes in an hour. That will give you the detention time in hours of 1.87 hours. All right, question 9. How would you solve the previous question if the flow was 0.4 million gallons a day? Again, so we had the detention time in minutes, tank volume gallons divided by flow rate gallons a minute. So 28,050 gallons divided by gallons a minute. We're going to do 0.4 times a million gallons. Give you 400,000 gallons per day. We're going to divide that by 1,440 minutes in a day. Give you an answer of 277.78 gallons a minute. We're going to divide the 28,050 gallons, 277.78 gallons a minute, which leaves you with an answer of 101 minutes. Again, conversion sheet, getting numbers off that will help you get your answers to your questions. All right, question number 10. What is the surface overflow rate of a sedimentation basin if the basin measures 10 feet by 12 feet and is 8 feet deep, and the flow rate into it is 700 gallons per minute? Again, on our formula sheet, hydraulic or surface loading, it says surface overflow rate. It would be the total flow applied divided by the surface area. Total flow was 700 gallons per minute. Solve for the surface area, right? So square feet, so we're not doing volume here. So the square or rectangle area, length times width. We don't need the depth, right? So they've given you more information than you need. They're showing you what they want as the units of measurement, right? Square feet. So you're doing the basin 10 by 12, 10 again feet, 12 feet. An answer of 120 square feet, 700 gallons per minute by 120 square feet. Gives you an answer of 5.8 gallons per minute per square foot. Question 11. What is the surface overflow rate of a sedimentation basin if the basin measures 10 feet by 12 feet and is 8 feet deep, and the flow rate into it is 2 cubic foot per second? All right, so same question, we just changed the flow rate into cubic feet per second. So we're going to need to do some conversions. We're going to go from seconds to minutes because we want gallons per minute. So 2 cubic feet per second times 60 seconds in a minute. Answer that, 120 cubic feet. Well, we want gallons per minute. We have 120 cubic feet per minute from the last math problem. And we are going to times it by 7.48 gallons per cubic foot. We get you 897.6 gallons per minute. divided by the 120 square feet we got from multiplying 10 by 12. Answer to this question is 7.48 gallons per minute square foot. Question 12. Water treatment plant uses 30 pounds of alum to treat 1.2 million gallons of water during a 24-hour period. What is the polymer dosage? All right, so this is a dosage problem. Dosage problems use the Davidson pie chart. There's a nice little explanation right here how the Davidson pie chart works. Again, this is on the Florida formula sheet. Not going to go too much into it for this. Might do a video later about the Davidson pie chart. So like with all math problems, your knowns and your unknowns. So we have our formula here, pounds per day. We're assuming it's 100% purity because it doesn't tell us otherwise. We divide it by flow in million gallons times 8.34 pounds per gallon. We had 32 pounds divided by 1.2 million gallons a day times 8.34 pounds per gallon. Do the bottom math first, 10.008. 32 pounds divided by 10.008 gives you 3.2 milligrams per liter. Question 13. Water flows through a 10-inch inside diameter pipe at a rate of 1.3 foot per second. What is the velocity of the water flowing through this pipe? Again, flow rates and velocity. Velocity is the flow rate, cubic feet per second, divided by area in square feet. 1.3 cubic feet per second, because I gave you the flow rate. Just have to find the area, square feet of the pipe. Said gave you 10 inches. It's going to be square feet. Convert the 10 inches to feet. 10 inches divided by 12 inches a foot. 10 divided by 12 inches in a foot would have given us 0.83 feet. We're going to square this. Area is 0.785 times diameter squared. That gives us an answer of 0.5 square feet. 1.3 cubic feet per second divided by 0.45 foot inside diameter of the pipe. Give you an answer of 2.4 cubic feet per second. All right, question 14. Water flows through a 10-inch inside diameter pipe at a rate of 400 gallons per minute. What is the velocity of the water flowing through this pipe? All right. Answer is in cubic feet per second. So we already solved the inside diameter of the pipe in the last question. It was 0.54 foot squared. We have to do some conversions. 400 gallons per minute. Come down to cubic feet per second. So there are 60 seconds in 1 minute. 400 divided by 60. 400 divided by 60 gets you 6.67 gallons per second. Answer is in cubic feet per second. There's 7.48 gallons per cubic foot. Divide. All right, the answer to that was 0.89 cubic foot per second. Divide it by 0.54 square feet. Your answer is 1.65 cubic feet per second. All right, question number 15. The hydraulic grade line is located 150 feet above a point in the pipeline. What is the pressure at that point in the pipeline? So to get PSI from feet, 2.31 foot of waterhead is equal to 1 PSI. In the conversion sheet, so 150 feet divided by 2.31 is an answer of 65 PSI. Question 16. If your standpipe is 95 feet tall and 35 feet in diameter, what would a pressure gauge read if the gauge was 5 feet above grade? So giving you a lot of information here, solving your problem. Again, the conversion, every 2.31 foot, you get 1 PSI. So the pressure gauge is 5 feet above grade. You take that 95 minus 5 feet, because you're not reading it at the bottom, give you an answer of 90 feet. 35 feet diameter is irrelevant. Just height, every foot, 2.31 feet is pound. Pressure, do the division. Answer is 38.9 psi. Question 17. A filter has a surface area of 240 square feet and filters 900 gallons per minute. What is the filtration rate? Filtration rate or backwash rate is flow rate gallons per minute divided by the filter surface area in square feet. We've already given you these, so we don't have to solve for anything else. 900 gallons per minute divided by 240 square feet to an answer of 3.75 gallons per minute per square foot. Question number 18. A filter has a surface area of 240 square feet and filters 2.1 million gallons per day. What is the filtration rate? Again, the equation for filtration rate is flow rate in gallons per minute divided by the filter surface area in square feet. We have the surface area in square feet, but we need to get the flow rate into gallons per minute. 2.1 million gallons a day, a million, to 2,100,000 gallons per day. And when you go to your conversion sheets, 1 day is equal to 1,440 minutes. Gives you 1,458 gallons per minute divided by 240 square feet, which is going to give you the answer of 6.07 gallons per minute per square feet. Question 19. The chlorine demand of a certain water system is 3 milligrams per liter. Plant treats 250,000 gallons of water, 10 pounds of chlorine gas per day. What will the chlorine residual be? Now we're going to use the Davidson pie chart. Part of this is you have to have the flow in million gallons per day. 250,000 divided by a million gives you 0.25. We know the pounds of chlorine gas, that's going to go on top of the chart. We're looking for the dose, 0.25 million gallons a day times 8.34 gallons gives you 4.79. The demand of the system is 3 milligrams per liter. 4.79 milligrams per liter minus 3. For your demand, it's going to give you a chlorine residual of 1.8 milligrams per liter. Question 20. How many pounds of 5.25% bleach would be needed to treat 900,000 gallons of water at a dosage of 3 parts per million? Again, for dosage problem, we're going to use the Davidson pie chart. So what we know is our dosage, our gallons. We can solve for the bottom. And flow has to be a million gallons per day. So divide the 900,000 million, get 0.9 million gallons per day times 3 milligrams per liter for your dose. Parts per million would be either parts per million or million grams per liter. They're the same. Times 8.34 pounds per gallon. It's going to get you 22.52 pounds. And the purity of the bleach is 5.25. So you're going to multiply that as a percentage. 5.25% is 0.0525. Will give you an answer of 428.9. All right, so like I said, that's just a quick 20 question study guide and kind of how to use the formula sheets and find the formulas, answer the questions. I'm doing this for me to prepare for my state exam. Hopefully it helped you. I might be putting out some more. Maybe they'll be better quality later.